Welcome back. We're in lesson 67 today. We're going to review equivalent equations and then we're going to talk about elimination. We've said that equivalent equations are equations that have the same solution. Thus, the solution sets for the equivalent equations must be equal. So, for instance, in these two here, x plus 4 equals 6, and x squared minus 4 equals 0. When we solve both of these, we subtract 4 from both sides. On this one, that gives us x is equal to 2. When we add 4 to both sides, on this one, that gives us that x squared is equal to 4. And when we unsquare both sides, we see that x is equal to 2 as well. So these are what we would consider to be equivalent equations, right? But these equations are not equivalent because this equation has another solution that is not a solution that is equal to this, and that is -2, because -2 times -2 also gives you the square root of 4, or it gives you 4, because a negative times a negative is a positive. And when we take this solution and we plug it into this equation here, we get -2 plus 4 is not equal to 6. That would be 2 is equal to 6, and that would be incorrect. So we remember that if every term of a particular equation is multiplied by the same non-zero quantity, the resulting equation is an equivalent equation. What that means is that every one of these that we solve for must be true for this as well. So if both of these solution sets work, then they are both true. Otherwise, we only select the one that is true as our answer for the two equivalent equations. Okay? All right. So let's talk about elimination for just a minute. And I don't mean that kind of elimination. I mean numerically. Thus far, we've been using substitution to solve systems of linear equations. But now we're going to talk about a new method called elimination. And elimination is actually a little bit faster than the substitution method. You still have a couple of different steps, but you're going to line up both of or all of the terms such that you can just kind of cancel them out. So let me show you what I mean by that. If I have this system equation, x plus 2y equals 8, and then I have 5x minus 2y is equal to 4. All right, what I can do is I can compare these two equations, and I can see that, let me move this over for just a moment. I'm going to move this to the side because I want to work this both ways to show you that both substitution and elimination give you the same answer. All right, so these are our two systems of equations. And I'm going to solve this one with substitution and this one with elimination. All right. So with substitution, we would solve this to be x equals 8 minus 2y, right? Remember that? We would subtract 2y from this side and 2y from this side. So we get x is equal to 8 minus 2y, and then we would substitute that in. And we would say 8 minus 2y times 5 for this term minus 2y is equal to 4. So we just took this and we subbed in the value of x here. Okay? So that'd be 40 minus 10y, because 5 times 8 and 5 times 2y, minus 2y is equal to 4. Okay, so we want the y's on this side, so that's a negative 12y. We're going to subtract 40 from both sides. Sorry, that's a 4, not a 40. Minus 40 over here. That's going to equal negative 36. So y, if we divide both sides by 12, negative 12, then y is equal to 3. Right? So now we know that the y is 3, but then we had to go back and sub it in to figure out what x was. So if we use the original term, if y is 3, then we say 2 times 3 is 6, right? So it'd be x plus 6 equals 8. Subtract 6 from both sides, x would be equal to 2. So our answer would be 2 and 3, right? That's what we get from the substitution method. So let's see what we get from the elimination method. With the elimination method, we see that we already have a positive 2y and a negative 2y. And if we treat this like a math problem and draw a line under it, these two would cancel out and give us 0, which would leave us 6, 8. I'm sorry. 6, 8. I looked at this number up here. 6x, because we know that a variable by itself has an imaginary 1 or an invisible 1. 5 and 1 is 6x, and this would be 12. We divide both sides by 6. X is equal to 2. That's the same one we got over here. We got to x faster, though. A little bit faster. So now we just sub in the x value here. That'd be 2 plus 2y is equal to 8. We subtract 2 from both sides. 2y is equal to 6. We divide both sides by 2. Y is equal to 3. 2 and 3, 2 and 3. You get the same answer both ways, but elimination is just a little bit faster than substitution. I highly recommend that you use elimination as much as possible, and you only use substitution when you have a lone variable or when you have numbers that are already very large and you can't multiply. You can't get past them. You'll start to figure out, okay, this is a better problem for elimination. This is a better problem for substitution. Now, when you have problems that already line up, where you have a positive and a negative that are opposites of each other of the same value, elimination is obvious. You know you want to use elimination because you don't have to do anything extra. You can just go straight into solving for the other variable. All right, so that will save you a step. All right, so that is an illustration of elimination. So let's do some practice problems with elimination. So we have for 67.1, we have 2x minus y is equal to 13. And 3x plus 4y is equal to 3. Now, there's two ways you could do this. You could say, you know what, I'm going to multiply this one. If you don't have two numbers that are the same, you have to multiply to get them there, right? Whatever you do to one side, you have to do to the other. So multiply the whole thing by 4. So you could say, I'm going to multiply this by 4 because I already have a negative and a positive number here. That gives me 8x. That gives me negative 4y. And 4 times 13 gives me 52. Yeah, that's 12, carry 1, that'd be 52. Right? All right. So now we're going to combine these. Now that we have these opposites here. Those cancel. We have 11x is equal to 55. So x is equal to 5. So we write our answer here in our ordered pair. That's the value of x. All right, now we take this and we sub it in to find the value of y. I'm going to use the smallest form, the smallest numbers, so that it's easier to solve. So 2 times the value of x, which was 5, minus y equals 13. That's 10 minus y equals 13. 10 subtracted from both sides leaves me negative y is equal to 3. If I divide both sides by negative 1, then I get that y is equal to negative 3. And that would be my answer there. Y is negative 3. Now the interesting thing is it doesn't matter which one of these equations you choose. So if you had chosen this one, the 3x plus 4y, you could have said 3 times 5 plus 4y equals 3. 15 plus 4y equals 3. Subtract 15 from both sides. You get 4y is equal to negative 12. Divide both sides by 4. Y is still going to be equal to negative 3. So it doesn't matter which one of these equations you pick, you're still going to get the value of y is negative 3. And that could be a way to check your work to see if you have the right answer. Do both of the equations that you're originally given and see if you get the same value for y out of both of them. And if you do, then you know that you've got that problem correct. Okay? Let's do another one. Let's do 67.2. So this one gives us a system of equations that looks like this. 2x minus 3y equals 5. And it also gives us 3x plus 4y is equal to negative 18. All right, so here's the deal. These two we're going to have to multiply by the opposite of each other. Or these two, we're going to have to multiply by the opposite of each other. And looking at that, I would either have to multiply everything here by negative 3, or I'd have to multiply everything here by 2. I think I want to choose to do the x's this time and multiply by 2, simply so that I don't have to get, I can do negative 18 times 2 in my head. Not so much 3. So it's just an easier multiplication. That's why I'm choosing to do this one. So we're going to multiply everything here by 2 and everything here by negative 3. And the reason for that is I need this to be a positive 6x and I need this to be a negative 6x. Okay? So that's what we're going to do. So I'm going to rewrite this. Negative 6x plus 9y equals a negative 15. And I'm going to rewrite this one. Positive 6x plus 8y equals a negative 36. Now I can combine those. I can eliminate that. This is going to be 17y is equal to 1, carry the 1, negative 51. Right? Now, it just so happens when we divide by 17, y is equal to negative 3. Right? So I can go ahead and start filling in my answer that, let's go to do a y there. Y is negative 3. So now I need to find x. I'm just going to take one of my original equations and sub in for y, and I think I'm going to use this one. So 2x minus 3 times negative 3, which is the y value, is equal to 5. So that is going to be a negative times a negative. It's going to be positive. So 2x plus 9 is equal to 5. When I subtract 9 from both sides, I get that 2x is equal to negative 4. X is equal to negative 2, because this and this divided by 2 leaves a negative 2. So negative 2 is my x value. So the solution for this problem is negative 2x, negative 3y. All right. I'm going to give you a set and I'm going to let you solve it yourself. That's 67.3. We have... Are these the same? Oh, they are. All right, so we have 2x minus 3y is equal to 5. And 3x plus 4y is equal to negative 18. With this one, the first one we did x We solved for the x variable. So this time, let's multiply to make the y variable the same. Okay. Actually, I think we'll do this one together, and then I'll let you do 67.4 by yourself. So this time we're going to do the y values. So we already have a negative and a positive, so I don't have to change the sign of anything. I just need to multiply by the opposite number, which in this case that would be 4 here and 3 here. So that gives me 8x minus 12y equals 20, and 9x plus 12y equals negative 30. No, 3 times 8 is 4, carry the 2, negative 54. All right, now I can combine. That's going to cancel. This is going to be 17x is equal to 20 subtracted from 54. That's going to be a negative 34 remaining. All right, and 17x, divide both sides by 17, that's 1x, so x is equal to a negative 2. All right, which is the same thing we got before. And now we take this and sub it in. I'm going to sub it into this one. So we get 2 times negative 2 minus 3y equals 5. Negative 4 minus 3y is equal to 5. Add 4 to both sides. I get negative 3y is equal to 9. Divide both sides by negative 3. Y is equal to negative 3. So negative 2, negative 3, just like in the first problem. So you can see it doesn't matter which variable you choose to solve for. You're going to still get the same answer. Okay? If you do it correctly, whether you use substitution or elimination, the first term or the second term, you're going to get the same answer. And that is, again, another way for you to check your work. Solve it solve it in different ways. Try this way, then try the other way, and if you get the same answer, then you know your work is correct. So let's let you guys do this one by yourself, 67.4. So we have 2x plus 5y equals negative 7, and then we have 3x minus 4y is equal to 1. So I want you to use elimination or substitution, preferably elimination, to solve for x and y. Okay? So pause the video and work those out, and then check for your answer by pressing play. All right, if you solved yours, whether by the value of x or the value of y, you should have gotten that x was negative 1 and y was negative 1 as well. So I chose to do the y term because I already had a positive and a negative, and it's just easier to multiply that than to try to multiply with a negative sign and have to deal with the symbols. Just depends on how I feel that day, basically, which one I solve for. So anyway, I solved for the y by multiplying that first so it would cancel. Then that left me 23x is equal to negative 23, so x was negative 1. So when I sub negative 1 in for the value of x on 2x plus 5y, I got negative 2 plus 5y equals negative 7, added 2 to both sides, got 5y is equal to negative 5, divided by 5 on both sides, and I got y is equal to negative 1. So the answer should have been negative 1, negative 1. All right. And that is all we have for lesson 67. I will see you ladies in lesson 68.